Hello, we are going to look at an example today where we're using both a normal and a binomial distribution. Once again, I am sorry, I can apparently not speak today. So we're going to look at some supermarket spending. So we've got some historical data that customers at the supermarket, they spend different amounts of money, and the historical data shows that the amount spent per consumer is normally distributed with a mean of $85 and a standard deviation of $30. If 500 customers are in a shop in a given day, we're going to answer two questions. What is the mean and standard deviations of the number of shoppers that spent at least $100? And then what is the probability that at least 30% of all customers will spend $100 in a given day? So let's go to our model. And so since the amount spent per consumer seems to be normally distributed, we are going to go and we want to know the probability that a customer will spend at least $100. So if we go into our calculation, so normal, it is normal.dis, the normal distribution, not S because it's not a standardized normal, it is just a normal distribution. Now if we do it this way and say $100 is the X value that we're looking at for the probability, the mean is $85, the standard deviation is $30, and we want to say true for cumulative. Now remember, if we type it in like this, that is the percentage chance that it's going to be 100 or lower. Because all of these things all start with to the percentage to the left of the query point. We want to know to the right. So we want to know what's the chance that it's going to be greater than 100. And so what do? We take a 1 for 100% minus the chance that it's going to be less than $100. And that's going to tell us, given this normal distribution of data, that there is a 30.9% chance that somebody is going to spend at least $100 that day. Okay, and so next we're going to look at if we have 500 customers coming in and we want to know what's the probability that they're going to spend at least, the probability that at least 30% will spend $100. Now what we have going on here is now we're in a binomial distribution because we've got a decision, 1-0. Because it's going to be, you've got 500 people you're going to test, and the question is, did you spend $100? Yes, no. There is no partial, there's no continuous function between that. It's a binary 1-0. You either did or you didn't. So, how do we calculate that out? So what is the mean of our binomial distribution? Well, the mean is going to be the probability that this is going to happen. In this case, it's are they going to spend $100 times the number of instances that we're going to try. So in this case, it would be the mean is going to be, we have 500 tests, and there is a 30.9% chance that that test is going to be spent at least $100. So the mean of our binomial is 154.27. So what is the standard deviation of this? Well, it's going to be the square root of, we're going to take the number that we have, we're going to multiply it by the probability that it's going to happen, and then we'll multiply that by 1 minus the probability it's going to happen. And so what we end up with is equals square root. Okay, and so the square root is going to be, still going to be B10, our number of customers, times the probability that's going to happen, so B7, and then we're going to multiply that by 1 minus the probability that it's going to happen. And so that gives us a standard deviation of 10.33. We need these to run our binomial distribution. And so now what we're going to do is, what is the probability that at least 30% will spend $100? So once again, now we're looking to the right. We're looking at who's going to be over our point. So we're going to have to do 1 minus the probability. So if we just, once again, we'll just do this. So if I go to my probability binomial distribution, and so our number is going to be, one second, our number that we're checking is going to be that at least 30% of those people spend $150, $100. Oh, we have to actually calculate that out. So let's, we'll come back to this here. So let's do that. And I'll just do that over here. So we'll do it down here. Number of people who spend $100. So the probability at least 30% of the people, so this would be what? This would be equals 500 times 0.3%. So 150 people would be 30%. Okay. So we want to know the probability of people that will spend at least 100. So you look over here at our note. So 30 times 500 is 150. So what's the probability that X will be greater than 150? Well, what we're going to do is we're going to take 1, which is 100%, and we're going to subtract from that the probability that X is going to be less than 149. I do 149, not 150, because once again, there is nothing between. It goes 149, 150. There's nothing in between the two. And so if I want at least 150, I have to take 1 step down, so 150 is in my data set. So we would go in here, binomial.dis, and once again, gotta hit tab. So binomial.dis, so our test would be 149, because I want to know what's below that. Our number of trials is going to be, well, B10, because we've got 500 people going. What is the chance that that's going to happen? Well, we've calculated out that probability is going to be 30.09%. And we want to know cumulative. So if I did this right here, this is the chance that it's going to be less than 149 people. So that's my probability. This is the probability that X will be, greater than or equal to 149. And so then if I subtract from that 1, that will give me the chance that 30% of the people, this is now is the chance that 30% of the people will spend at least $100. Because this right here is 100%. Well, we know 100% of the people are not going to spend, that 100% of the time, 30% of the people are not going to spend $100. This right here is the probability that 149 people, which is right below 30% of the population, is going to spend that amount of money. So 1 minus this is going to give us the percentage chance that at least 30% of the people will spend $100. And so once again, just look right over here. It's might be a little bit confusing, but if you think about it, it's not too bad. The problem is we're getting the probability of a percentage, and that's where sometimes it might take a little bit to wrap your mind around it. Okay, hopefully I explained this really well. If not, please ask me a question about it, and I will do a better job.